Okay, good morning, everyone. Let's have a quick review of what we were discussing last time. Last time we already started with multiple linear regression, but I feel that there are still some items that I want to discuss as regards the simple linear regression. So kindly go back to your codes. And the first model that we ran was this one, model one, where we were doing a linear model on regressing hourly wage on education using our data wage. Okay, and this is the result of this. Okay, so the result was this is the intercept, this is the education, and the model there is that the wage. Hindi pa makita yung digital pen ko, class, nawawala. The wage is equal to the intercept negative 0.9. Let me just cut it to one decimal place plus 0.54 times education. Times education, hirap mag-ano sa mouse. Okay. And then you have plus error term. Plus your error term, E sub I. Okay. To remove this error term plus, you have to change this. You have to make this as wage. Okay. Hat, which means that this is the forecasted value. So we can erase this now. The forecasted value plus is equal to negative 0.9 plus 0.54 times education. Okay. So this is your forecasted value. If I remove the hat here, class, then you'll have to insert here plus epsilon sub I. The epsilon sub I, class, is the difference between this is your actual value, class. Without the hat, it is the actual value. And then this is the predicted value, this is the model value. So the difference between the actual value and the predicted value, in order for the actual to be equal to the predicted, dapat may yung correction niya, yung epsilon sub I, no? Dali lang, class, ha? Okay. So any question about that, class? Any question about that? Clear yun, yung equation and wage is equal to negative 0.9 plus 0.54 times education plus your epsilon sub I, your error term, your residual, or your E sub I. Class clear? Magsulat ng ano. Waiting for your feedback, class. Kung may question, paki-question. Kung naintindihan, pakilagay ng yes, class, para hindi ako magtatagal, class, maghintay sa inyo. Okay, thank you. Thank you, please. Thank you. Thank you. So, request lang, class, no, please. Let's respond faster. Kasi naglalag time tayo, class, eh. I'll be wasting a lot of time waiting for your response kung if you have a ready response naman. Whether it's a question, clarification, please do so. Please inform me about it, ask questions. But if it's clear, class, please say so also, class, no? Okay. So quickly, class, the meaning of the intercept is that's the value of your dependent variable wage when all your predictors, when your predictor is equal to 0. So this means that this is the hourly wage. It's negative 0.9 if your education is 0. So you have a respondent, okay, and he has 0 years of education. Then we say that the average hourly wage is negative 0.9. Of course, that does not have any meaning at all. Kasi kung wala kang education, ibig sabihin mo, ikaw yung magbabayad sa company. You're the one going to pay the company with negative with 0.9. Kasi the negative here indicates that from the perspective of the hourly wage, negative means it's the respondent going to pay because it's negative, right? So this does not have any practical significance. Okay. In fact, it's not significant at all. It's 0.17. Nevertheless, it's still included in the model. So you still put it as part of the model. Wage is equal to negative 0.9 plus 0.54 times your education. All right. Then we see here, class, that the education is significant at 0.001, right? This one. Significant at 0.1% or at 0.001 level of significance. I can't move kasi I can't move this if this not so good about the zoom. Okay. All right. Then we have here residual standard error. Okay. As we continue, class, you'll have to know how to compute for this. On 524 degrees of freedom. How did you get this, class? The formula for the degrees of freedom is n minus k minus 1. So n is the number of observations. And if you take a look at the wage data set, there are 526 observations. Minus k is the number of predictors, and then minus 1. In our model 1, there's only one predictor, education. Okay, so this is minus 1, and then another minus 1. The minus 1 here accounts for the degree of freedom lost because we're estimating the intercept. Okay. Now, if we plot that class, if we plot the regression line, we know that it will pass through this one, negative 0.9 here. This is negative, let's say this is negative 0.9. Okay, so your regression will pass by that one. Okay, it's also possible to let's say not include the intercept in your model. Not including the intercept in your model means you're regressing to the origin because you're saying that I want the intercept to be 0. Okay, so if you do that, class, you're actually saying that you're regressing through the origin. You're letting the intercept pass through 0. Okay, so there are of course pros and cons of doing that, but let me not discuss that now. So 524 degrees of freedom, where did that come from? Number of observations, n 526 minus k, number of predictors, which is 1, minus 1, which accounts for your intercept, because we're not regressing to the origin. So in the intercept is being computed, so that means you have to deduct 1 because there's a loss of degree of freedom if you're computing for the intercept. So that's 524. That's how you got this. Okay. Multiple r squared, 16.48. Adjusted r squared is 16.42. Okay. So this one indicates that 16.48% of the variation of your dependent variable hourly wage can be accounted for by your predictor education. Okay, we'll discuss adjusted R squared. This is more relevant if it's multiple linear regression. So for now, our model can account for 16.48% of the variation of the variability of your dependent variable. Remember that it's your dependent variable that we're trying to model. Okay, and 16% of that, its variability, its variation can be accounted for or can be explained by education. What about the 83% plus? Okay, it simply means that 83% can't be explained by education only. So how do you address that? Then you'll have to put in more predictors in order to increase the what can be explained by your model. Okay, so FSTAT class. So this will now be we'll discuss this class when we go to multiple linear regression because it's really more really more relevant to that, yung F-stat natin. But you see here that there's 2 degrees of freedom, degree of freedom 1 and degree of freedom 2. Okay? The degree of freedom 1 class referred to the number of your predictors. So here it's 1 because you only have one predictor. The degree of freedom 2 is the same as this one. It's n minus k minus 1. So it's 524 also. Okay. And then you have a p-value here. Okay. So it means that you're inferring something here, you're testing something here. So for your f-stat, okay, and in this case, you're only testing one parameter, which is b1. So this is also b1 is equal to 0. So that's your null hypothesis. b1 is equal to 0. Okay, so you're testing if b1 is equal to 0, which in this case is just the same as the test here. Okay, the individual test. b1 is equal to 0. Okay, so b1 is equal to 0 dito. Ang inference natin, we reject the null hypothesis that b1 is equal to 0. Kasi di ba, this is significant at 0.001, di ba? So, 0.001. This is 3 stars. So dito yung level of significance niya, no? Okay? If it's significant at 0.001, then obviously it's also significant at 0.05. Kasi this means, class, that the p-value is less than 0.001. And definitely this p-value is less than 0.001. Okay? All right, so let's continue on, class, kasi may mga items pa dito which I have discussed, which I feel should also be discussed before we really go into multiple linear regression. All right. So this one we already discussed before, di ba? Sinolve na natin to. Okay. Di ba sinolve na natin to last time, right? Am I right, class? Could you kindly confirm? Okay. So we learned how to compute for the coefficient beta 1, which is just this is just, class, the covariance actually to, no? If I put here divided by n minus 1, the complete formula here, as we said last time, is there's a divided by n minus 1 here. Okay. The complete formula is that there's a divided by n minus 1 there. Why was it removed? Because here also there's a divided by n minus 1. So this is actually the covariance of x with y, and this is the variance of x. Variance of x. There. Okay, so if you divide it, if you cancel the divide by n minus 1 and just perform this, then it's the same. You get the getting the covariance of x and y divided by the variance of x will just be the same as getting this product divided by this product. Okay, so let's that one we have discussed. So just continue. I'll have to remove the okay. Right, so here I think we discussed this. This is what I was showing you a while last time, class, yung covariance divided by the variance. Okay, and then we also learned how to get the intercept, which is the formula for that one is the intercept is equal to the mean of y, the mean of your dependent variable minus the mean of the independent variable, okay, multiplied by your slope. So this will tell us, class, that the regression line will pass through x mean and y mean and x mean. Okay, so the regression line will always pass through the point where it touches the average of x and the average of y. Okay. So did I share this class formula with you, the standard error? Class?
Iba po, sir.
Yeah, sige, ito class, i-share ko lang to yung formula ng standard error para lang we're not going to really discuss that much, but I just want you to be familiar for the formula for the standard error. Okay. So the standard error class is standard error of your slope is the square root of this one. So medyo a bit complicated yung yung formula. So it's just your dependent variables of all your observations for your dependent variable minus the predicted value, corresponding predicted value, and then square root. So what's this class? What's this? Could you please tell me what's this class? Anyone? What's this class? What do you call the difference between your actual value minus what's this? What does this stand for? What does this stand for? That's your no, that's not that's not the mean class, this one. The y hat. Ano to class? No, that's not the dependent variable class. What's this class? Hello, class? Kaya explain ko lang yan kanina. Just explain that a while ago. No, that's not the mean. Okay. Simon, Audrey, kindly share your answer, please, to everyone. Pag nag-answer kayo, class, please, paki-share sa lahat, no? Di ba, class, yung y hat natin, di ba, predicted value yan. Diba? If you see that symbol, class, if you see that symbol, y hat, class, y hat, predicted value yan, class. Where do you get the predicted value? How do you get the predicted value, class? How? I-illustrate ko ulit kasi mukhang looks like hindi nyo nakuha, no? How do you get your predicted value? Your predicted value, class, is generated through your model. Diba? Meron tayong value ng intercept. Meron tayong value ng Okay. Balikan natin. Hindi pa nakuha yung concept ng Mod 1 class. Names. O, dito na lang. I-print natin si Mod 1. View. View Mod 1. There. So, tingnan natin, no? Ito. Mod 1. Yan, di ba? Ito yung laman ng model natin. Ano laman niya, class? Diba? We looked at this before. Sabi natin, it contains a rich amount of information. Number one, nandiyan yung coefficients. The coefficients is the answer to the model. But this is the intercept. This is the slope of education. Why education? Because we have one regressor. Ang regressor natin si education. So this already gives us the model. The model is your hourly wage, diba? Your hourly wage, your wage variable is equal to the intercept, which is this one, negative 0.905. This is what I wrote a while ago, diba? Plus 0.541, 0.541 times education. Education, okay? So this is your predicted value class, predicted value. And you represent that by wage there, wage hat. Okay. Now your predicted value is not the same as your actual value. So when you get the difference between your actual value, wage sub I, minus your predicted value, wage hat sub I, the answer there is your error term, epsilon sub I. All right. So your wage, your actual value class, wage sub I, is equal to, if you transpose this, this is equal to your wage hat plus epsilon sub I. But what's this class? This is your negative 0.95 plus 0.54 times education, right? So you get me, class? Clear ba yun? So when you let's just let wage be equal to W, no? So this one, class, is your predicted value. Okay, so every time you see this, that's your predicted value. So dito, class, makikita natin, no? Andito yung fitted values yan. Your fitted values are your predicted value. Pareho lang yan, class. They're the same. Okay, so if you want to check, okay, let's see. What class is the first, what class is the first value for your wage? 3.10, di ba? 3.10. Okay? So if we compare, class, if we compare 3.10, wala. So your actual value is 3.10. So that's your wage sub I. Hirap pong sulat ng ano. Sorry, class, wage sub I to. And it's equal to 3.10. That's wage 1. Sub 1. Yung first observation natin. Okay? Are you following me, class? Clear so far? Yung wage sub 1 natin, that's 3.10. Kindly chat, please, if you're following.
Yes po.
Okay, how about the others? Paki-chat, please. Good. All right. Now, let's compute for the predicted value for the W sub 1 hat. How will you compute that? We have the model, negative 0.905 plus 0.541 times education. Okay? So how do you do that? Paki-ano nga, class, sa console? Please copy yung negative 0.905 and then plus 0.541 times education. Can you please do that for me? Anyone? Any volunteer, please? Everyone, please do that. You can copy the 0.905 dun sa mod 1 and then add natin plus 0.541 times education. Education of the first respondent is 11. So you replace your education with 11. Okay, what do you get, class? What are you getting? I'm only seeing 3 respondents. Huh? Saan galing yung 0.541? Sige, balikan natin yun, ha? Saan galing yung 0.541? Okay, tinan ulit natin, class, yung model natin. Balikan natin yung natin. So, ayan, class. Yung sa summary, di ba? I-delete ko ulit ito, ha? Delete. Ayan. Summary model 1 class. Control enter. Ayan, class. Slope ng education. Then we explained this last time, di ba? Anong ibig sabihin? What does 0.541 mean? It means that for every 1 year increase in education, there's a corresponding $0.54 increase in your hourly wage, ceteris paribus. Okay? Yan, class, 0.541. Sinortcut ko lang 0.54. No? Okay, does that answer your question, please? Nasagot mo yung question na yun? Okay, so what's the value class? What's the predicted value for, let's go back to observation number 1. Okay, observation number 1, the education is 11. The hourly wage is 3.10. Okay, we're predicting the hourly wage, right? This is what we're modeling. Okay, you have the actual value here, wage sub 1. Then we would like to know what is the predicted value. What's the predicted value? Negative 0.9, okay, whatever that complete value is, plus 0.50 something times education. So can you kindly do that, class, and tell me how much that value is? How much is the predicted value for observation number 1?
Sir, I got 5.046.
5.046.
046.
How about the others, class? Pakichat nga, please, what you're getting. I want everybody to please chat. I want everybody to do it, class. How about the others? I'm not getting the others. I'm not getting the answer of the others. How do we do the code for this? Ano yung Carlos? Anong code yun? What code are you asking? Carlos? Pwede mo i-calculator dito. Sa console na lang. Pwede naman dito, class, di ba? You can use the console. The console is a very big calculator. Don't have to use your calculator, class. Kasi sa exam nyo, hindi naman kayo pwede mag-calculator. Diba? Use your console. Andito naman siya, oh. Yan. At saka yung kanina, sa result kanina. Diba? It's there. Or if you want, class, andito din yon, no? Diba? I think I illustrated this last time. So si mod 1 class, diba, meron siyang, ayan, no, coefficients, diba? Yan, coefficients. Pero yung coefficients, dalawa yung class. Negative 0.905 at saka 0.541. So I'll just get the first one. So bracket 1. So this one will give you, diba? Ano yan, class? That's your 0.905. Ayan, no? That's the complete intercept. Naka-ano lang kasi ito, naka-truncated lang siya. Okay? So, if I want, class, kung gusto nyo talagang formula, mod coefficients, and then the first one, which will be your intercept, and then plus mod 1 dollar coefficients, and then the second one is your slope, then multiplied by, kasi this is your beta times your slope times your education. What's your education? Diba 11? Diba? 11 siya, diba? Yung first observation natin, 11 years. If I run this, control, enter. So this is your, okay, this is your answer, class. This expression where you're multiplying, where you're adding yung intercept natin plus the slope times 11. Okay, 5051. Okay? Then, ano yung unang ano natin, class? Ano yung unang actual value natin? 3.10, ba? 3. Okay. And then I'm going, class, to subtract the actual 3.10 minus, ayun natin sa parenthesis to, 3.10 minus the predicted value. Okay, kasi yung buong value na to class, that's your predicted value. So this is your W sub I minus your W hat sub I. Control Enter. Okay, what's this class? What's this? What's that class? That is your, what do you call this class? The difference between your actual value and your predicted value is your epsilon, okay? Or that's your residual, di ba? That's your error term, that's your epsilon, that's your residual. Correct. No? Correct. So can we see this class? Ano? Can we see this in your Model 1 results? Mod 1, dollar. Okay, andyan kasi residuals. Residuals. Let's just take the first one. What's the first residual class? Control Enter. There you go. Diba? So tama. We were able to confirm that indeed the residual class came from subtracting your actual value, okay, minus the predicted value. So if you take a look at Mod 1 class here are your residuals. There are 526 residuals all in all. And why is that so? Why is that so, class? Because you have 526 observations. You have 526 actual values. You have 526 predicted values. Therefore, you'll have 526 residuals. Okay, so just for one more checking class. Let's take a look at observation number 2, 3.24. I'll just go up arrow, up. Okay, I'll just copy this class. I'll just change this. So the actual value is 3.24. Okay, minus, so this is again the intercept, plus this is the slope. That's the second element in your coefficients. What do I multiply that with, class? Can you tell me, please? So what do I change here? Correct. Thank you. So, sabi ni Waki, you replace 11 with 12. Why? Because 12 is the number of years of education, right? So I'm going to replace this 12. Okay. So Control Enter. So the difference is negative 2.35. So let's get that Mod 1 dollar residuals class, residuals. And then let's get the second one, number 2. So what's the second residual class? Diba? Exactly the same. All right? Okay, let me pause for a while and allow this to sink into you. We would want class to understand the output, yung model 1. What's inside that? Okay, so I'll wait for your chat, class, for you to signify that you're following so far. Take your time, class. There are 30 of you, class. So far only 11. Okay, thank you. Feel free, class, to ask any questions if you have any. Okay. So let's now go back to so I hope, class, it's clear, no? This one is clear, yung mga elements na to. Of course, we didn't really discuss everything, but the others are really self-explanatory. Kunyari, yung call, this is the function, hourly wage regression education. And ito yung formula lang, hourly wage regression education. And the model class is a list. Okay? It's a list, 526 by 2. 526 rows of observation by 2 columns as far as the model is concerned. This one, class. Okay. So it pairs, class. Notice here, class, model, no? The name of this is model. So mod $1. Okay, so I can ask for that model, this one, class. There. Control Enter. So there you go. So it contains the side-by-side comparison between, okay, your actual hourly wage, okay, actual hourly wage and your education. So it's just a printout of your dependent and your independent variable. Okay, because your wage data, but this is coming from your wage data, and your wage data contains several variables. So here it's just listing what was your dependent variable and your independent variable. Okay, and you can actually, class, create a, let's say, I'm going to create data, alt minus, and then mod $1 model. So there you go. I created an object class, a data frame. Here, take a look. Here, data class. Diba? And I can add here the predicted value. I can add here the predicted value. I can add here the error term. Okay. So how do you do that, class? How do you add here to your data, this data set? So this is, again, a practical application of our data wrangling. We can add here another column if you want to create a column here which contains the actual you have the actual value. You can put here the predicted value. You can also put here the residual. Okay, that's easily done. But I'll just give you a hint, class. You can use cbind for that. Column bind. You're going to add a column here. Okay, then another one here. So, but I'll not discuss that now, class. I leave that to you as an exercise. But it's just column bind, cbind. Okay, so back to saan ako? Why am I here at nasa arena ako? Sorry, na-combine yung ano ko ah. Okay. So Okay, this one class. This one. So let's just quickly discuss this because it's important class for us to understand the asan yung model 1 natin. Okay, so this was what I was before I went on a lengthy discussion on what this is. So this is your predicted value, right? So this is your actual value minus your predicted value. So this one is actually your residual. Okay, residual squared. So the standard error of your slope, so this is the standard error of your slope, it's equivalent to the standard deviation of your slope. Okay, and you measure that by getting the sum square of the square class of the differences or of your residuals. No? Squared residuals, sum natin siya, divided by, so this is the deviation from the mean. Your predictor, education minus the average, okay, and then squared, and then multiplied by a factor 1 minus n minus 2. So that's your standard error of your slope. Okay, so we can actually show class that sa model natin, layo na. Here class, diba? 3.378 residual standard error. Okay. How was that obtained, class? From this formula. Mouse is so here. So the residual standard error class, no? This one. Okay, so we'll not do that anymore. Okay. Okay, this one, class. Let me just share this with you because this is very important. Yung T-stat, control C, control V. Okay. So your T class, how do we compute for your T? Sa model natin. Ito class, the T value. How was that computed? It was computed by your beta class, by your beta, and divided by your standard error. So there, class. Beta minus your standard error. Standard error of your slope. Okay, so if we're, for example, class, ito. This one. How was this computed, class? Simply this one. Okay, so your estimate divided by your standard error. Control enter. There, negative 1.32. So the T value, how is it computed? The formula is your estimate divided by your standard error. Same thing here. At 10.167, 10.167. Yes. Paki-share yung question mo, Rene, sa ano? To everyone, please. Okay, question is the estimate the same as beta? Okay. The answer is yes, class. So the estimate of the intercept, that's called your beta null. So this is your beta sub 0. Okay. This one is your beta sub 1. So they are our betas. They are our slopes. Okay. Okay, so what I just want to point out here, class, is how were these values generated? How were these values computed? So we're just making use of this simple linear regression first. Okay. Okay, so this one, just Control C, Control D. Ay, sorry. Ba't nung ko pa sinabi? So here's another set of formulas, class. Mouse ko talaga medyo okay. So what happened here, class? Your t-stat for B1 is equal to your B1 times standard error of B1. Can you run this, class? Class, can you run this? Will this run? Why or why not? SET1? Ano SET1? Files. SEB1. Okay. So why will this not run, class? You should know the answer already very quickly, no? Because these objects are not defined. Si B1, nag-define mo na ba yan? Wala naman eh. Ba? Nag-define ako dito, no? Okay, in my case, I defined B1. In your case, wala. So hindi siya magra-run. So paano magra-run to, class? How will this run? Answer, class? How will that run? I gave a formula, class, na ano na before this, may create na object. Siyempre, class, you should have guessed by now that this will not run because in your case, there's no object called B1. Okay, that was deliberate on my part. So that's why you have to create first B1. I was expecting you to quickly answer that, oh, of course, that will not run because in your case, you haven't created what this object is, right? So you have to define that B1 is, okay, so for quick just calculation, you can just copy this, right? For now, no? But you can actually get that from mod 1. So for now, diba? Ayan. So that's your B1, right? Sorry. Your B1 class is this one. That's your slope, no? Your beta, this one. Sorry. So your B1, you can directly get that class. Mod 1 dollar. Sorry about that. Coefficients. Dollar. Coefficients, right? That's what we have been doing. Coefficients, and then that will be your number 2, right? So if you run that class, you'll now have your B1 and your standard error of B1. Okay, you can actually get that class also from mod 1, but let's just copy it for now. This one. Control C. Control V. And when you run this class, run this. Therefore, you can now run this. You can now get your T-stat for B1, which is your B1 divided by the standard error of B1. Okay, I'll give you a few seconds to do that class. And if you run this, you should be getting the T-stat, di ba? Asan na yung model 1 natin? Here. Ito. 0.54136 divided by this one, you'll get 10.167. You'll get your T value. Hello, class. I would be needing your feedback, class, if you want me to repeat something or if something's not clear. Now, what's the rationale, class? What's the rationale? Why are we looking at this? I want us to be very familiar with the anatomy of this output. No? I want us to know where these are coming from. Kasi if we'll just leave it as that, saan nanggaling yung mga yan? Parang hindi pa nga tayo masyado nagdi-deep pa kasi hindi pa natin, ito nakuha na natin to, di ba? Yung estimate. We were able to show the formula for, let's say, B1, which is just the covariance of X and Y divided by the standard deviation of X squared, variance of X. And then the t-value class is just the quotient of your estimate and your standard error. This divided by this, that's your t-value. Okay, waiting for your chat, please. Is everything now getting confusing? Remember, ang target lang natin, class, at least maintindihan natin, at least for us to be able to understand where these are coming from. Yung estimate, we already have done that. Okay, standard error, we didn't really show the formula for that, but I gave you the formula there. Diba? Ang standard error. Ayan, class. This is the formula for the standard error. And then the t-value is simply your estimate divided by your beta divided by your standard error. So waiting for your confirmation, class, kung clear sa atin yung t-value natin. Okay. All right. Thank you. Now, third, class, ito, yung P. This one, the probability. Because we need this, class, we need this. Either we can base it on the t-value to determine if the parameter is, if the variable is significant or not. Okay, you can use the t-value or the p-value. so far what we have been looking at is the p-value. So how was this obtained, class? This p-value. How is it obtained, class? All right, it was obtained, class, by using a function in R. Okay, so you have here the distribution that we're using is T distribution. T-stat nga yun, di ba? T-stat. And if we want to compute, class, if you want to compute the p-value, you have to understand, class, how your T distribution works. Your T distribution is quite similar to your normal distribution. Okay, so this is, let's say this is your T distribution. So you want to compute for the probability. So when you say probability, class, say this one, you would want to compute for this probability. So you'll have to know this value. You'll have to know this T-stat. Now the T distribution is symmetric. So you either get this probability here, or you can get you can get it from here. So this is your negative T, and this is your positive T. Okay, so this is just a quick review of your basic statistics class, no? But what we're interested in is how do we get this from R? Okay, we're not going to use a table. We're not going to use a T distribution table, but rather we're going to use the function. And there's this function, class, called PT. Okay, probability at T. Okay, so if we clear the drawings and then here, class. Okay, di ba I gave this to you, class? So we would like to compute for the probability. Okay, and I'm using this function, this name PT underscore for B1. Okay, alt minus, and then PT, class. Okay, take a look at this, class. Ano yung hinihingi, class? PT. What's being asked? Number one is your Q. Tapos DF, tapos may NCP, tapos lower that tail is equal to true, tapos my log that B is equal to false pa, no? So the syntax seems to be quite confusing, no? Pero actually madali lang yan, class, no? Okay, so ang unang hinihingi is okay, Q. Ano yung Q natin, class? What's our Q? The Q there is your T value. Balikan natin to. If it gets a bit confusing, class, okay lang yun, no? Kasi nagsisimula lang tayo dito, no? Kasi kailangan natin malaman to, class, no? Okay. Ano yung T-stat natin, class? Di ba ito yung class? Di ba ito? We obtained it by dividing your B, okay, with your standard error. This is your T value. Kay R, ang tawag niyo dyan Q. Yung quantile, no? Yung value ng T. 10.167. Okay, so ito yung hinihingi niya ng una. Next one, ano hinihingi niya? What's being asked for, class, is your degree of freedom. So ano yung degree of freedom natin, class? Diba that's your N minus K minus 1. Right? N minus K minus 1. Ano yung N natin? That's your N row. N row ng wage. That's your 526. You could have typed it to be 526, class, no? Pero ginamit natin yung ano, yung function na number of rows na wage. And then minus 1, okay, which is the number of predictors, and then minus 1, this is the number of, this is to account for your intercept. So this is your degree of freedom. Okay? And then, hinihingihan pa tayo class ng ito. Kung yung NCP, we can ignore that. Saka na natin explain yan. Yung lower that tail. Okay, what does that mean? Lower that tail, is it true or false? Now, of course, class, the best way to do this is yung usual, no? Kukunin natin class yung ano. Kaso hindi, nagkakaproblema lang ako sa ano ngayon. Sa view class, no? Sa help function. Nagkaka-internal server ako. Can anybody please share this muna kasi I'm having a problem with my R. Anyone please? Suwan ko dito. Even if I get it from here, internal server. Can anyone please share the yung PT class, please? Stop share lang ako. Would like to share class yung PT, yung sa helper, please. Wala. Okay, wala. Ayaw. Okay, so tingnan nyo na lang
Sure, I
class.
can share po.
Oh, pero ang tagal nyo kasi mag-respond class eh. Kulang tayo ng ano, ng maghihintayan tayo, no? And that it's up really on the time, no? Ano na lang class, I can't show it kasi nagkaka-internal server ako, I'm sorry. So you just take a look at this class and then try to decipher bakit lower that tail is equal to false. Okay. Yan, bakit lower that tail is equal to false. If you run this class, I gave this to you, control enter. What will you have? And the parenthesis here class tells us that, okay, yung parenthesis na yan class, ibig sabihin yan, i-print yung answer. What do you get class? 1.39 times 10 to the negative 22. Pero class, yung t-value natin dito is, tingnan nyo 2 times 2e to the negative 16. So, what does that tell us, class? May discrepancy. Which means, class, that this is not the actual p-value. Technically speaking, the p-value is this one. Yun. Okay? This one. Kaso nga lang, why is it showing 2e to the negative 16? Now, the actual p-value is much, much less, no? Negative 22 to eh. Ito class, negative 16 lang. So 16 decimal places to the left lang versus 22 decimal places to the right. Now, this is the reason class. So, you notice class kasi minsan pag nagre-result ng regression, madalas ganito, no? 2e to the negative 16. And minsan pare-pareho pa, no? Especially for very small values. Parang it defaults 2e to the negative 16. Does that mean that this is really the value? No class, no. The answer class lies here, yung floating point. So let me just share this with you. So this is where now your something about the floating point comes into play. Which, okay, ito class, medyo torn ako, no? Should I discuss this with you? Is this that important to you? So I've been doing that for the past past terms kasi I feel na importante din siya. So paki-copy na lang to class. And then let's just let's just make sure that whenever you see 2e to the negative 16, it does not really mean that that's the actual p-value. Okay, and what's the reason, class? The reason there is that, ano ba yun ako? Okay. Sa limitation class, sa machine language, no? All right, take a look at this. The number 2e to the negative 16. So, in-explain ko yan. Okay? Ano ba yung ano? You can check your machine class kung ano yung pinaka-double na, ano yung pinaka-smallest possible, smallest positive floating point, okay, that can be generated, that is generated. Okay, ano ibig sabihin ng smallest floating point number? Okay? Yung number na yan is such that 1 plus that number is not equal to 1. Okay, so medyo nakakalito yung ano, yung concept, ano? Okay, but let's just run that class. What is the smallest number that R considers to be not equal to 0? So that's actually the question there. So what's that smallest number? So i-run nyo nga to, class. This one. That machine dollar double dot EPS. Okay, take a look at that, class. Okay, so ano yung implication yan, class? What's the implication there? Anyone, class? What do you think? Ano yung implication ng ano yung small number na yan, yung 2.22, which is what's reflected on? And based on the probability that we computed, diba, class? Based on this probability that we computed, hindi naman, it's not 2e to the negative 16. It's even 2e to the negative 22. It's much smaller than that. But why is it that R is just reflecting yung 2e to the negative 16? Okay, and the reason is this, class. So it's just reflecting the smallest point so that if you add that number, 1 plus that number, class, 1 plus that number, it will not be equal to 1. Okay? So, tingnan nyo, class, no? Try this, class. Try this, class. 1 plus whatever this value is, di ba? Ito yan, right? This one. Or you can, let's let x be equal to this number, which is this one. And then let's check if 1 plus this number.
You're not screen sharing.
Oh, I'm not. Huh? Since when? Ay, oo nga pala. Naku, sorry, class. Nga pala, I was requesting you, anyone to share screen. My bad. It's not a good day for me now. daming hindi ko malabas yung ano ko. Okay? So, quickly now, class, back to what I was discussing, ito, no? The number 2e to the negative 16. Why is it that when we have when we, let's say, get the regression results, why is it that the probability shows this one? And it's many times you'll see this, class. So just be aware that that's not actually the p-value. The p-value is actually much less than that. This is the p-value, in fact, for education. So it's really more significant. It's more statistically significant than this one. But R just chooses this one. Okay? It just chose the smallest possible floating point. Because in a sense, class, this will require more memory, this one. Numbers such as this. And it will not be, let's suppose that the answer is negative 100 to the negative 100. It will not really make a dent if it was negative 100 as compared to this number. So it just presents this number because that's the smallest possible number, so that 1 plus this number will not be equal to 1. Okay, so let's take a look at that class here. So that number class is this one. That machine $double.eps. Okay, so let's let x be equal to this number, which is this one. But that's that number, which that's the number that appears in your regression model. So if I run this, so I'll now have x here. X. Where's my x? Here. Take a look, class. This is my x. 2.22 times 10 to the negative e to the negative 16. Okay, what will happen if I add 1 to this x, class? So this, it's asking, will it be equal to 1? So this is a true or false question. Control enter. So what's the answer, class? The answer is false. What does this mean, class? What does this mean? What does this mean, class? So this is the smallest number, that t2 e to the negative 16, so that if I add 1 to that number, it will be greater than 1. Greater than 1 na siya. Okay? If I add 1 here, class, Control C. Okay, I'll call this, what's that? What did we call this? It's PTB1 here. I'll copy this, class. Control C. Control C. PTB1. So 1 plus PT underscore B1. Okay, and let's check. We should have placed it. Is this equal to 1? What's the answer, class? If you run PT underscore B1, you got negative 22, right? Now, if we add that 1 plus PT underscore B1, what do you get, class? Is it a true or a false? Answer? Yes, true. Okay, so what does that tell us, class? It tells us that this one is practically 0. But that one, class, is practically 0, while this one is not. 2e to the e negative 16 is practically not equal to 0. Why? Because if we add 1 plus that value x, okay, 1 plus that value x, it's actually, okay, we're checking, right? Is 1 plus that machine double EPS equal to 1? No. Is 1 plus x greater than 1? Let's check that, class, please. And it's almost time. So we'll just end in this lesson. 1 plus x, class, is it greater than 1, class? Yes, it's greater than 1. Okay. There. 1 plus x is greater than 1. So what's happening, class? In order to save on memory, okay, R chose the smallest floating point. Okay, it's the smallest floating point, so that when you add this very, very small number to 1, it's not anymore 1. It's a value greater than 1, but it's not really significant, because if you add 1 plus, and then you have 16 zeros, right? 1 plus 0.00000022 something, okay? So in terms of significance, it doesn't matter. It does not change at all the inference that might be derived from that. Okay. However, what we're doing now here is that R is now saying that, okay, the p-value is let's say 1.11 times 10 e to the 100, negative 100. So let's just represent it by a number, okay? By a number of no, still the same, of no consequence, but it's the largest floating point number, so that if you add 1 to it, it will be already different from 1. And definitely, class, 2.2 e to the negative 16 is of course greater than this 1.11 times e to the negative 22. No? So that's the point there. To save also on memory, to save also on computing. Okay, so it's more of a practical. It's more of a practicality. Okay. Anyway, class, when you're doing statistical inference, uh, whether it's e to the negative 100 or e to the negative 16, it's the same conclusion. It's the same conclusion. So you don't actually need to say where are the p-value is 3.5 times e to the negative 56. You don't report that in your statistical analysis. Hindi kailangan, that's not needed. So if it's a number that's less than 2 e to the negative 16, then R already converts it into 2 e to the negative 16. So that's what we get for the p-value there. That's the reason why, and you're still going to meet that, yung 2 e to the negative 16. You'll notice that there are lots of values like that, and it doesn't mean that the probability is exactly that. Here we're saying the probability is, we know that, class, it could be this one, but most probably it's less than this one. So R just chose the smallest, smallest floating point here. And we were able to show that the actual value is this one here. Okay, so I know, class, that this is just a bit of a nitty-gritty detail about how the p-value is generated, but I hope so I just wanted to, I felt so uncomfortable last time, to be honest with you, because I glossed over it, and I was thinking that I'll just go to multiple linear regression quickly, but I felt that this is something that that should also be known by you. Okay, so let me just, okay, up to analysis of variance, control C. So for next meeting, class, we'll go back to this one. Okay, the recording, class, okay, as I said last time, I'm not anymore going to load it. I'll just post it in YouTube para mas madali, no? Kasi minsan I'm having difficulty loading it in Canvas. So I'll just post it in YouTube. So please, may I request you to, okay, paki-subscribe na lang, class, Control C. Let me just share this also with you. The other codes we're going to discuss this next meeting, okay, so that I'm comfortable that analysis of variance, I gave it. So from here, please just copy this also, these codes also. Okay, let's see, with no predictors, Control C, Control D, okay, and then the rest also. Make sure you copy it, class, please. Okay, we'll discuss this. I think that's the last one. This is still a continuation of this one, class, very important for us, SSR, SST. This is one of the reasons why I wanted to go back. Maybe up to this one, SSR, SST. Control C, I hope it fits. Difficult to, where did I end? Fstat. There, F-stat, ANOVA F-stat. This one, I think, 317, extracting, SSR, SSE, SST, SSR. $372, let's see. Let's see. Oh, guessing game, sorry. Just up to 350. Let's see. Okay, then one more plus 351. I'm giving this already class so that you can, because we want to finish this next meeting. I think this is the last one. Let's see. Okay, that's about it, class. Okay, so thank you so much, class, for your patience. Should have ended recording already.